Hello, everyone. Welcome to tech sessions of the 9th of December. We had a wonderful presentation last week uh, of Dr. Andreas Gimsa, and want to point out that we are making a lot of strides in quantum gravity, and he has looked very deep into the understanding of how gravity works and how it is related to electromagnetism. So that's a great progress, and it is very similar to the work that I am doing with quantum gravity as well as Christopher's and Emmanouil's and even Jones and probably Christian, who are all scientists in our forum. And we had a wonderful discussion uh, last week, and we hope to continue this week, but everybody seems to have been busy otherwise. So I just want to give a brief overview of you know uh, the progress and also what we plan next year. We plan to have a series of uh, based on the history of physics that happened over the last few centuries. I would say from 16th century onwards, uh, around the time that Galileo, just after Galileo, uh, discovered about gravity, and that we are still grappling with the real physics of it. So we have to go back to the historical perspective, how classical physics came into being, and then thermodynamics, which formed the fundamentals tying of energy itself, a statement of energy, and also entropy, and eventually the time itself that we are still puzzling to know how these work. And I have worked more on the time aspect, and one of the aspects that I have come is that the time may not be one dimension. That we think if you have six dimensions, it's a manifold, uh, but it is a virtual manifold, like a Calibu-Yau manifold, and so we have to grapple with that aspect. And recently, I also found that as discussions with Christopher also that what I thinking about the error function was the original solution for the diffusion equation of uh, developed by Fick's uh, considerations. That's more physical chemistry that, that I was originally involved with in the material science aspects. So the diffusion is a fundamental and also real thing. Observables, observations, that's mathematically deep understanding of space and time itself. And then everything seems to have developed from there, even quantum mechanics to some degree. And you see similar equations. The equations are developed from there. So you could adjust uh, the solution for vacuum, which is exactly the function, uh, from the Schrodinger equation. The Schrodinger equation, the solution itself, you can see that the solution is a separation of variables that you can see as space as a function of space, the wave function as a function of space, and wave function as a function of time. And that seems to be working well, and all the quantum physicists in the advanced level think that the solutions really uh, you know portray the actual things, like for example hydrogen atom and other aspects, and also the spectra that we see, the signal spectra that we see, they are all seem to manifest that you can consider space and time separately. So if we are doing that, then Christopher's 4D space that he's considering uh, with his configuration of geometry of space, and what I'm considering presently is the six dimensional. aspects of time, they can be combined together to get a whole picture of what it is. And my original general transforms show that the whole universe is like a black box. And Gerd thinks that we are in a supermassive black hole. We are within massive black hole. The Emmanouil's work, which spanned a lot of things, including superluminal, uh, gravity, gravitons, and how everything can be explained on that basis, is a very great stride forward. And when Dr. Andreas Gimsa talked about, how minutely and deep within it is all either magneto-electric gravity or electromagnetic gravity. And the reason we'll be looking into the history of physics could be that during the time of Newton, the quantum aspects of you know atoms or the quantum aspects of matter was not well known. It developed, and the fields aspect came later on with Maxwell. So, which means that what they consider as neutral, matter, that Galileo, when he dropped from, you know, from the tower, the leaning tower of Pisa, uh, he found that all the matter, regardless of the weight, can uh, fall together at the same time. So, these are the things we'll go into more detail with experts at different levels who are more familiar with that, uh, commenting on that, and also describe that. Eventually, we'll have to have compiled videos, and then hold a Hawaii conference meeting that we come together in person. Later on, we develop movie and things like that, so that eventually, when the World University is formed, we can show that, uh, you know to have everybody in the same page. So the idea is that during the time of Newton, Galileo Newton, it was considered as the deeper structure of the atom was not known by that time. Well, not at least not well known. So, they consider as neutral atoms, and how the forces act between neutral atoms was a big puzzle for the man. This all in terms of gravity, that it's some you know um, action at a distance aspect. Uh, that it's centrocentric to the, for example, Earth or any other objects that attracts it, and that is the one that keeps all the objects together, including the solar systems, star systems, the whole universe, uh, held together by gravity. Otherwise, everything will fly off. You know. Uh, so this is the fictitious force, or uh, implicit force, that was puzzling to uh, all the scientists. And when classical physics, then with Maxwell equation, came up the understanding of electromagnetism from Faraday and Gauss, and then many other scientists. Uh, and then when Rutherford split the atom and showed that there are particles within them, like electrons, positrons. So they are not really neutral particles. So if you think of a matter as a neutral entity, it may not be really true, because the electrons and the protons, for example, like protons are hydrogen atom, hydrogen ion atom is like a proton, that I have studied in detail in material physics, especially with respect to the degradation or the corrosion of materials in the environment. So the hydrogen plays a very critical role in that. So the hydrogen is ionized, or hydrogen as a proton that can go deep into the material and create embrittlement, things like that. So we know the structure of these atoms from the periodic table, and the synthesis, that they are real. So the quantum physics and the particle physics goes much further than that, and they says that even these particles are formed of quarks, and and then there are more and more things, hadrons, and then finally the standard model talks about fermions and bosons, and the research is going on with the Large Hadron Collider to figure out what's inside the atom, or the particles, or what's the fundamental entity from which everything is formed. So this is a ongoing research, but the important thing to note here is that what we consider as the neutral atom or neutral matter may not be really neutral. So in that case, we have to consider the quantum aspects, what we call the quantum gravity, which means the electromagnetism plays the key important role. The only difference is that they may cancel out. So they may appear as neutral, but they are charged. So they actually have forces in them, the magnetic force and force that Dr. Andreas Gimsa has himself looked into how these internal forces act on each other, and he has described the way that when you consider all that together, currently, and how they all sum up together, they eventually create the gravity. So gravity is not a fundamental force in that sense. So I also looked into that and say that there's two types of gravity. There's a weak gravity and strong gravity, and the gravity itself is formed from uh, creating sphere of influence. That means that if we consider that deep within the matter, uh, any object, that you have these atoms, and deep within that is the fundamental uh, magnet magnetic effect, that what that John is saying, and also the fundamental aspect that magnetic uh, you know magnetism is very deep within the fundamental thing because of the electrons, and also the nuclear magnetic resonance shows that they all have a magnetic field within them. So magnetic field is more fundamental than gravity in that sense. So we can easily argue that, although the quantitative developments and still are very challenging, and with the development we have with all our scientists that on this forum have come together and able to do both qualitative and quantitative description of quantum gravity, is a big step forward. So essentially what we are talking is that, and my research and recent publications, peer-reviewed publications, show that uh, this sphere of influence, for example, a large body has a larger sphere of influence. So because of the field, automatically they're within. So there is an intrinsic field, quantum field within, because of electrons and uh, protons, which becomes like positrons, the fundamental level, and also neutrons, supposedly neutral atom, but they are consists of electrons and positrons. So eventually, everything may be breaking down to electrons and positrons. That our research showing that may be the most fundamental aspects, and how they come together is because of the field effects, electric and magnetic field. The magnetic field, moving magnetic field creates electric field. There's a fundamental aspect that Maxwell equation and then Faraday experiments, all that has proved. The question of uh, typolarity, that Gauss theorem says that a magnetic cannot uh, exist as monopoles, but they, even if you break any magnet, again you have north-south aspect. So dipolar aspect is the fundamental thing. But that's where the superluminal aspect that I and Emmanouil has came about. The superluminal level, everything, the monopolar can exist, uh, in terms of a Cogmeyer, that even grand theory of everything, has proved the theory of you know supersymmetry and all those things finally have proved our theory of everything, what we call it now, has proved there has to be monopoles at the fundamental level to create that much of energy that we see to create matter. So that may be a necessity, but I have found also that there could be quantum black hole, which are called micro black holes, which forms from the superluminal level. And the fundamental mechanism outlined is so far is a hot PDP mechanism. Many of them have problem with the question of observability, being observation. It may not be observable in the normal sense, so it's a theoretical construct in that sense, and that's the problem with the string theory also. But I think we can go further than that to develop the weak gravity and the strong gravity, which eventually could be proved that indeed is true. And the weak gravity is actually like a open string, uh, whereas weak gravity is a closed string or loop. So we have forces all uh, coming together or internally centrosymmetric forces can develop in the loop system. And the loop itself may form four-dimensional topology, like toroid and things like that. Uh, but they can concentrate both centripetal and centrifugal forces, and that creates stronger gravity. Whereas open loops have fields in them, but they are weakly interacting because real forces come at the ends and they join together, but there is nothing that concentrated forces. So I have shown that if we consider sphere of influence, we can show that although the magnetic effect, they they overlap each other, and then you have attractive force. So it always then forms an attractive force, which is what we call the gravity. So gravity is an effect of this causality of the electromagnetism and also the creating densities, um, which are called sphere of influence, which creates uh, quantum density of matter or quantum density uh, of sphere of influence that spread over space. And in time, they interact with each other, and you can show, has shown schematically how then they can create what we see as gravity. So gravity is a fundamental force, but when you go into deep aspects of the quantum aspects, we see that these are happening. We have to prove how that's happening over a long distance. Um, right now, we know about quantum superposition, which is being developed. And also recently, there was an experiment at Oxford that was published that showed that they could develop a monopole by having a tip, a diamond tip, uh, having an electron that's moving over a hematite, which is magnetic iron, and that creates monopoles in the system. So that's a very, very recent, like the last week or two. It's the most recent development that really there could be evidence for monopoles. And that has been the biggest problem. Although monopoles is a conjecture, it has not been proved. But I think the future experiments probably will bring out the fact that monopoles really exist. But they immediately form dipoles. So we have to, the residence time of monopole in the real world is, very small. So immediately they form dipoles. They cannot exist as monopoles in the real world. So what we talk about real world or observable universe. So from the point of multi-phase systems, we have superlunar system where everything goes faster than speed of light. and you have the cogmare with the monopoles and everything that creates that noisy energy, so to say. But we cannot observe them, we cannot see them, we cannot tap them. But then they form the hot PDP mechanism and they create vacuum which holds the speed of light constant. And now the particles can pop out through the phase of vacuum and create subluminous phase that you have fermions and bosons coming there and acting together, and they create real observable universe that we see. Now, the quantum field theory and the aspects also point out to false vacuum and true vacuum. So I have developed a model, a schematic model where you can see how the fermions may be forming in the true vacuum. Bosons and hadrons and mesons can form the false vacuum because it's higher potential energy. So if we see the uh, Schrodinger equation, the for two vacuum you could consider the potential energy to be zero, and essentially you can solve as an error function. And from there, you can get the understanding of the fermions. Whereas in two vacuum, we have to consider higher potential energies. And now the Schrodinger equation has been solved in terms of separation of variables of space and time, and eventually show how the strong force come into picture. So the strong force probably is in the crucible of occurring in the crucible of the false vacuum, if you can think of that way. And then the fermions, the weak force, may be occurring in the crucible of the vacuum. The crucible of vacuum is the infinite one. So it's actually a flat space one can consider. So you have a flat space and also a curved space in the false vacuum. So these, the curved phase, you can have strong forces coming into picture because of the mechanism I briefly told a little while ago. And in the uh, true vacuum, we have flat space. So you have the weak forces coming into picture. So I think we are able to uh, figure out how exactly they all come together. Uh, so we can describe a consistent mechanism of interaction of strong force and the weak force in terms of the false vacuum and true vacuum. And then they construct together. And then if you have a wormhole that connects between force, that also I have briefly schematically described wormhole, a micro wormhole, so to say, between the force vacuum and the true vacuum. Now we have a way, a conduit through which gravity and you know the other forces, the electromagnetic force also comes to complete the circuit. So the electromagnetism comes from the circuit that connects between the out- outside, between the true vacuum and the false vacuum, and they form a clocking mechanism, the gravity going. So the gravity effects and electromagnetism, the strong and the weak nuclear effects, can be described how they all come together. The concept of false vacuum, true vacuum may be important, uh, and that's something we have to look into more because we have to quantify them and prove that indeed it can form. So that's a big challenge that's facing. But if that is true, then in that case, we can see why this ephemeral aspect of the universe, the epiphany, or that finally we have to describe why things construct or and why things destruct. So ourselves, our body is formed, but then after a while, we don't exist anymore. So this continuous process of life and death, and also of the universe continuously changing, is something that is very, very puzzling to us even now. And add to that, recently I found that analysis of the dimensions of time, or topology of time, and also the time loop aspects that I am working on now. Uh, that we are in a time loop, the 8-year time loop, that will change later on. But that's a specific characteristic that's happening of the time that we are in now. And that's how the time loops, they have certain characteristic, and it can be proved from the error function and the complementary error function aspects of space and time that I solved. And that, is specific aspects of the events that happen within that time loop. And then you have the next set of time loop, which has a totally different characteristic. And something called matrix protocol, and also some keys based on the inner product, outer product, things like that. Uh, those concepts of matrices as well, from which we can prove that how the communication comes out, and from that communication that we get, we are able to figure out how the whole the time loop works, and how it is configured, what's the logic behind it, the logic of the time loop itself. And then everything seems to be working together to understand. So how we are able to get that is that as time progresses, the noise is getting resolved. So the noise contains, at any point, space and time, the noise contains all information of the world, probably including aliens and other aspects. But we are not able to resolve that. But as time goes on, we resolve more and more into the noise. So the signal to noise amplification occurs with time, with proper devices, circuitry, switching circuitry, that our brains itself have that. So some brains are able to resolve that more than the others. So we get more and more deeper information about what's going on. So I have described one of these peer-reviewed papers, that how the information comes from global to the local, and that creates time, the locally, the clocking mechanisms, for example, the heartbeat beat mechanism, and that then the time aspect then goes out, so it creates that information time loop. That's a very interesting aspect. I think that will describe many other things, including communication and all the events that is going on. Uh, so they all come together, you know, uh, like gauge theory. They will come together, and you can describe them in a comprehensive fashion, in consolidated fashion. So I think they are all coming together, but the complexity is that, a Schrodinger equation, other things are shown, but also the general relativity, uh, which developed from the classical physics, that was more real aspects and much simpler aspects of matter interaction, and still true for macroscopic, many other macroscopic, uh, events. Newton's equation worked very well. The equation, and also equation of motion that Galileo developed, all of them are, you know, good enough to describe all of it. But when you go into the micro world, quantum level, or the macro world of astrophysics, there are a lot of differences. And right now, the quantum theory or quantum physics that we know of, the development of Schrodinger, is necessary to understand about the micro aspects or the quantum aspects, we call it, and all the way to Planck level. That's an ultimate level, that the uh, the real matter or the part seems to exist. Uh, the real observable universe is closely connected with that Planck space, but I think the more real aspect is Planck time itself, and then we multiply with the speed of light, the actual distance that we had to measure. That I worked with Emery Taylor about discontinuum theory, the discontinuum length, which describes the existence of matter, maybe more like 10 to the minus 26, 10 to the power minus 26 meters. So that's the smallest distance. Below that, it becomes more superluminar and an indistinguishable part of the universe. So that's a discontinuum aspects that we see. That's, we are developing, and we have proved through argumentation and also quantitative theory that may be the situation. Now, the macro world, of course, general relativity is with the question of black holes, and he's the one that's describing that really Einstein said that you know uh, the space itself, the gravity is not a fundamental, but it's a curvature of space time is what's causing gravity. So how that is creating the curvature of space-time may be created by the electromagnetism. So I think the concepts Einstein developed and also the Schrodinger may be fine, but why they have a inconsistency in terms of Viking catastrophe or gravitational catastrophe, maybe because we have to describe exactly the curvature of space and time, the- which is caused by electromagnetism, which is caused at quantum level, and that's not consistently developed, and there is a gap in between that you have to resolve to solve the problem, and that I think quantum gravity comes into picture in that. So you see that there is a complexity, no question about that. But the complicated aspect can be resolved by terms of splitting into complexity and simplicity. So when you talk about complex space, we say it's a real aspect and the imaginary aspect. But with the conjugation, we can convert that complex space into real space. So we have to understand a lot more about that as time goes on. And all of our research essentially is pointing there is a way to resolve these, come up with some sort of a grand unified physics. Talks about field, how the field comes into big picture to the quantum level, and how the density, matrix comes into picture from the question of, you know, uh, you know, larger space, the space. So the time aspect and the space aspect separately considered will resolve this confusion that we have. Hopefully, we'll be able to go on. So thank you very much. I just want to give a gist of what's going on. Hopefully, we'll continue next week, and we hope to have the history of physics and then the Hawaii Conference and the World University eventually materializing somehow in the future with all the cooperation and sponsorship and things like that we hope to achieve in the coming years. Thank you very much. We'll all see you next week. Have a wonderful week. Thank you.